So in today's lesson, we are going to talk about solving equations, just like we did yesterday. But today we're going to have some special case scenarios. And the first one I want to talk about is actually one of the questions from your practice from yesterday. This is question number 6. And I want to talk about this because there's actually something we have to do here that we didn't talk about yesterday while we were solving these equations. And let me actually make that look like a 4. So the first thing I have to do, since I have 2 sets of parentheses, I'm going to have to do some distribution. So I'm going to go ahead and do that on both sets of parentheses. So this is going to give me negative 12x minus 9. This set of parentheses is going to give me 24x plus 4. So one thing I notice is that I have 2 constants, 4 and negative 9, and I have 2 variable terms, negative 12x and 24x. Those are called like terms or similar terms or common terms. Typically, you'll hear them called like terms because they're things that look alike. Both of these have an x. And so instead of adding 12x to this, like I would if I was moving 12x to the other side, I'm actually going to combine the coefficients. So 24x and negative 12x combined together give me 12x. And then I need to combine my constants, which are also like terms, and negative 9 plus 4 gives me negative 5. Now, since I've combined all my like terms, I'm at a spot just like we were yesterday, and I can go ahead and start solving this just like yesterday's lesson. So I'm going to have 12x being equal to 48. I'm going to divide by 12, which gives me x being equal to 4. So again, the only reason we went over that together is because we didn't talk about combining like terms yesterday, and I wanted to make sure everybody was on the same page there. So the next question we're going to look at is 5 times the quantity x plus 1 being equal to 3 times the quantity 5x minus 4 minus 10x. Let me focus this a little bit better. So I'm going to go ahead and do my distribution, and I'm going to distribute in both sets of parentheses. So this is going to give me 5x plus 5 being equal to 15x minus 12 minus 10x. So I see like terms here on this side. So I have 5x plus 5, and I'm going to combine my like terms. 15x minus 10x leaves me with 5x minus 12. Now, you should be scratching your head a little bit right now. I have a 5x on both sides, but here I'm adding 5, and on the other side I'm subtracting 12. Any number that I substitute in for x, I'm going to do the exact same thing on both sides. But if I'm adding 5 to that number and subtracting 12 from that same number, neither side is going to end up being the same thing. So in this case, no number that I ever substitute in is going to work. These sides will not be equal. They will not be balanced. So this is called no solutions. there is nothing that we could ever use for x that would make these sides equal. We're going to go ahead and look at our next example here. We have 5 times the quantity x plus 12 being equal, or minus 5x being equal to 7. So the first thing I'm going to do is I'm going to go ahead and I'm going to distribute. So I'm going to distribute 5 to x and 5 to 12. So this is going to be 5x plus 5 times 10 is 50. 5 times 2 is 10. So adding those two things together is going to give me 60. So I'm going to have 5x plus 60 minus 5x equals 7. And I'm going to go ahead and combine my like terms again. Well, 5x minus 5x technically leaves me with 0x. But mathematically, if something is being multiplied by 0, it's just going to be 0, and we don't need to write that. So what we're going to be left with is 60 being equal to 7. Well, no matter where you go in the world, 60 is not going to be equal to 7. This is always going to be false. So this is another example of no solution. All right, let's go and look at number 4. So I've got 2 times the quantity x plus 10 minus 17 minus 2x being equal to 3. So I've got 2 times x and 2 times 10. So I'm going to have 2x plus 20 minus 17 minus 2x being equal to 3. And we're going to go ahead and combine our like terms. So I have a positive 2x and I have a negative 2x, just like over here. That would be 0x, but I'm not going to write that because, again, anything multiplied by 0 gives me 0. I'm going to simplify these constants here. So 20 minus 17 leaves me with 3. So I'm going to get 3 equals 3. Now in this case, this is a true statement. This tells me no matter what number I ever substitute in for x, I'm going to have a completely balanced equation. And since every number for x could work, this is called infinite solutions. Because every number you could ever think of would work for x and balance out that equation. All right, we've got 2 more. So the next one we're going to look at does have a fraction. Now, you could choose to divide by 3 first, seeing that 3x and 9 are both divisible by 3. What I'm going to do is get rid of this fraction and get rid of my denominator by multiplying by 2. But I have to be careful because I'm not just multiplying 3x by 2. I have to multiply everything on this side of the equation by 2. I have to maintain that balance. So what I'm really doing is creating another set of parentheses that I need to distribute through. So I'm going to have 3 times 2x plus 6 and 2 times 3x plus 9. And now I can do my distribution on both sides. So I'm going to do 3 times 2x and 3 times 6. And on the other side, I'm going to do 2 times 3x and 2 times 9. And now I have a point where my expressions on both sides of my equation are absolutely identical. This is the same scenario here. If everything on the left is exactly the same as everything on the right of my equal sign, it's infinite solutions. Excuse me. So the last one we're going to look at also has a fraction. Now, since ultimately I'm going to have to deal with a fraction, what I'm going to do is move the 3 to the other side. And now I'm back in a scenario like we were over here where I'm going to get rid of that denominator. So I'm going to multiply by 3 here. But I'm creating a new set of parentheses that I'm going to have to distribute with because there's 2 terms on this other side of the equation that I need to multiply with. So I'm going to have 2 times x minus 1 being equal to 3 times 4x minus 3. So we're going to go ahead and distribute. And now I'm going to go ahead and start getting x's together and constants together. So I'm going to, since we're on opposite sides of the equal sign, I'm going to have to do inverse operations. I can't do any combining like terms because they're not together. So I'm going to move x first. And I'm going to add 9. So this tells me that 7 is equal to 10x. And I'm going to divide by 10. So x is 7/10. And yes, I am leaving my answer as a fraction. If this is something that can be simplified, you would simplify your answer. But more often than not, in these types of questions, if your answer is a fraction, your answer choices on SchoolNet or on your EOC would also be as fractions. So we're going to practice leaving our answers in fractional form.